Hello students, so now we are going to see our next thing, that is maxima and minima. So this is just an application of we can say double differentiation that we just studied, okay, and we want to find out the maximum value of any function given, okay. This is like say fx, okay, y equal to fx is given. So we want to find out this particular point where it is maximum and this particular point where it is minimum. Maybe it is going ahead also, but we want to find out this particular point, okay, this local maxima and this local minima, okay. So how to find out that we're going to learn with the help of double differentiation only we are going to do, okay. So let's say I mark this point as a, I mark this point as b, and here I mark this point as c, okay. Now what I'm going to do is, let's say at a particular point, let's say I have this value is xa, and corresponding to xa the value is ya on the function, okay. So now what we have is, let's say all 3 points we will see it simultaneously. So at point a and at point b and at point C, we're gonna see simultaneously, okay. So at point A, what can I say is, so whether it's a the maxima point, or whether it's a minima point, or whether it's a C point, okay, dy by dx is always 0, right? You can see from the graph, right? Here dy by dx, the differentiation will be 0, right? So I can say dy by dx at A will be 0, right? And dy by dx at B will be 0, and dy by dx at C will also be 0, right? Now as we discussed in the previous video, that what we said is at a point when the curve is downward facing, so this at this point this will be d2y by dx square, the second derivative will be negative, right? So at the maxima at the a point, d2y by dx square is gonna be negative, okay. It's gonna be negative, and d2y by dx square at b, what can we say about b? It's gonna be positive, okay. And d2y by dx square at c, at what can I say, it will be 0, right? So this is no use of this point. But if I verified, first what will I do, I will first derivative I will calculate, I will put it equal to 0, okay, and I will find out that x value, okay. And for that particular x value I will check the second derivative sign, okay. If the second derivative sign came negative, that means this is point of maxima, okay. Second derivative came negative, then it is point of maxima, and if the second derivative came positive, that is a point of minima, okay. That's all. That is the point I want to make, okay. So if the curve is downward facing, we know from the previous lecture that this is the d2y by dx square going to be negative, and if the curve is upward facing, then d2y by dx square is going to be positive, okay. So this is point of maxima. How to check the point of maxima? Dy by dx should be 0 and d2y by dx square should be less than 0 at that particular a point, okay. Then the point that particular point is maxima, okay, point of maxima. And for that x value I will calculate the particular y value, the maximum y value, okay. Now let's see example, okay. So what question we have is, we gonna derive a step by step solution, you don't have to worry, okay. So first what we have to do is just note down the function, okay, then calculate the first derivative dy by dx, okay. So that will be 2x minus 5, right? Then calculate the second derivative, that is 2, okay. Now for point of maxima and minima, for point of maxima and minima, or minima we can say, right? So for point of maxima and minima, I can say dy by dx should be 0, right? Whether it's a minima or whether it's a maxima, dy by dx will be 0. So that is 2x minus 5. So what I got, x equal to 5 by 2, right? So at x equal to 5 by 2, dy by dx is 0, right? Okay, so that meaning at x equal to 5 by 2, it will be a maxima value. Okay, it will be a point of maxima, or either it will be a point of minima. I want to verify, right? So for that, what will I do? I will check the sign of second derivative. Now for verification, I will check sine of d2y by dx square. Then I find out that I don't even have to put the value of x. The d2y by dx square is constant, so that is greater than 0. So if it is greater than 0, see, we have seen if this is greater than 0, that point will be a point of minima. So we got a minima point. So what we got is, this is point of minima. Okay, got it? Okay, so what we can say is, so we got the x value 5 by 2. So at 5 by 2 it will be minima. So correspondingly there will be a y value, right? Okay, so what will the y value? Just put the x value in the main function. 5 by 2, you will get the particular y, minus 5 into 5 by 2 plus 6. So from here, if you solve, you will get y equal to minus 1 by 4. Okay, so the y minimum is minus 1 by 4. Okay, now let's learn how to draw the graph. Okay, how to draw the graph. So what I'm saying is, you have to check for plus infinity, x equal to plus infinity and x equal to minus infinity. So we have to check from where the graph is starting, and you check putting x equal to 0, what is the value of y. Okay, so when the x is 0, now how to draw the graph? When x is 0 in this function, I want to draw the graph of this function. Okay, we calculated the y minimum value, but still we will go one step forward and we will draw the graph of the function. Okay, so you put the x equal to 0, then y you got 6, means at x equal to 0, when the x axis, the point is 0, then y is 6. So it is passing through this point. Okay, that we done. Okay, and the x is 5 by 2 and the y is minus 1 by 4. So when x is 5 by 2 somewhere here, then y is minus 1 by 4, means somewhere here. This is the minimum value, okay, that the function is achieving at the local. Okay, now if I put the x as infinity, okay, then this quadratic, the x square will dominate over the x function. So you can say this is minus 5 times of infinity, but x square will dominate here. Okay, so this overall, this function is going to be positive, right? So this is going to start from the plus infinity. When the x is minus infinity, when the x is plus infinity, I put it plus infinity, then this is plus infinity, means here it is going to be end at plus infinity. And if I put it minus infinity, then already it's going to be square, so it's going to be plus infinity only, right? So when the x is minus infinity, the function is plus infinity only. So it is starting from plus infinity, passing through this point, then minimum achieving at this point, and then again going plus only at infinity. So how will be the graph? The graph is going to start from here, okay, and then come here, and then like this. Okay, let me draw it more correctly for you. Okay, like this and like this. It is not going to be steep that much. Okay, there are going to be a curve. Okay, so let me draw it for you people like this. Okay. Like this it's gonna be. Okay, let me make you more comfortable with this. It's gonna be a curve. Okay, we got the perfect thing. Okay, so here at x equal to 5 by 2, the y is minus 1 by 4. So this is what? Y minimum. Okay, the minimum value of y. So now you understood why it is started from plus infinity and ended at plus infinity only. Okay, so because x at minus infinity, if I put here x minus infinity, then x square function is going to be dominating. Okay, and this is going to get plus infinity, y is going to get plus infinity. So it is starting from plus infinity, ending at plus infinity, and at x equal to 0, curve is passing through 6. So means here. Okay, right? Some people will say, sir, why you didn't pass it here? That's why I checked the value. Okay, so this point is my, I can say 0,6. Okay, so this is how the graph is going to look of this quadratic function. Okay, so we calculated by maxima and minima. Now let's discuss one more question. Okay, then you're going to understand this thing more clearly. see here, okay, we have a cubic y equal to x cube by 3 minus 4x square plus 15x plus 4. Okay, first step, what we will do, y dash, that is 3x square by 3, so that is x square minus 4 to the 8 x plus 15. Okay, this is my first derivative. Okay, and then I will calculate the second derivative, so that is my 2x minus 8. Okay, so first, what is the step for maxima or minima, whatever. Okay, what will I do, maxima or minima? I will put y dash equal to 0. So at y dash equal to 0, what I got, x square minus 8x plus 15 equal to 0. I hope everyone knows how to solve a quadratic equation, right? This is very basic. Okay, so what I get from here, x, so if you get it, x minus 3, x minus 5 equal to 0. Okay, so x equal to 3 or x equal to 5, right? So at x equal to 3 and x equal to 5, both first derivative is 0, right? First derivative 0 means either this x equal to 3 or and 4 5 are maxima or minima, or maxima minima or minima maxima. We don't know, right? We don't confirm, but it is either a point of maxima or either a point of minima, but we don't know confirm that it's what. Okay, particularly, so for that we're gonna check the sign of second derivative, right? So let's see, second derivative we calculated. What is the second derivative? 2x minus 8, right? So at point, we can say x equal to 3, x equal to 3, y double dash is equals to 2 into 3 minus 8, that is negative, right? Y double dash is 6 minus 8, that is minus 2, so this is negative. So I can say this is a point of maxima. Okay, so here the value is getting maximum, and at point x equal to 5, what can I say, y double dash is equals to 2 into 5 minus 8, so that is plus 2, right? So y double dash is greater than 0, right? So this is point of minima. Let's get the exact coordinates. Okay, so we know the x coordinate, but we want to find out the y coordinate also. So x coordinate is 3, so if you put in the main function here, x equal to 3, then what you get, the value of y from here. Okay, I'm gonna make it easy for you. Okay, so when you will calculate, you will get this value as 22. Okay, so this is your point of maxima. Okay, and when you will solve for this point, so when x is 5, you will get 62 by 3. You can calculate. Okay, this is very easy. Okay, so this is 2 points of minima and maxima. Now let's go back and draw the graph. Okay, how to draw the graph? Let's see. Okay, I'm teaching you one step further, but it's still very important how to draw the graph. Okay, let's check at extreme position, that is plus infinity and minus infinity. So I will put x equal to plus infinity, then what I got, x plus infinity I put, then here x cube will gonna be dominating, so that gonna be put plus infinity, right? So graph is gonna end here at plus infinity, and if I put minus infinity, then this it will come minus only, so y is gonna be minus infinity, means he is for x minus infinity, y is minus infinity, means here. Okay, so it's gonna start here somewhere, he is gonna dance like curve here, and then after went plus infinity. Okay, like this, but what gonna happen here in between, that we gonna see. So what we saw here is we have 2 points, one is maxima and one is minima. So at x equal to 3, it is getting maxima. So at x equal to 3, okay, x equal to 3, so at x equal to 3, somewhere here, okay, somewhere here it is getting maximum value, this. Okay, let's say this value, this is 22. Okay, this is my 22 and this is my 3. Okay, and so it is coming from here like this, and then after here at x equal to 5, it is getting low, and then it is going back here. Okay, so at x equal to 0, I can say it is 4. Okay, so it is somewhere here. Okay, So how will I draw? It is gonna come from minus infinity and it is gonna cross here, and then it is gonna x equal to 4, it gonna touch, okay, and then it gonna be plus here maxima it gonna touch, and then it gonna touch minima, and then it will go at plus infinity. So let me draw you this clearly. Okay, so little bit, because I don't want to make it steep, this is little bit curve here. Okay, that's why, that's what. Okay, yeah, this is looking nice. Okay, so this is what, still it is not my satisfaction, to my satisfaction. Okay, and this is gonna look like this. Okay, like this. Okay, so this is my x equal to 5. Okay, got it. So at this particular point, what is the value? 22 by, I guess I wrote 62 by 3, sorry, 62 by 3, or maybe this point is 4 actually. Okay, so maybe it is below this. Okay, so little bit correction. So but this is what it's gonna look like. Okay, this will be 0 comma 4. Okay, so you can put x equal to 0, you will get y equal to 4. So by that, okay, so this is gonna be the graph. Got it? I hope you will understand this thing. Okay, this is your graph. Okay, I hope this is clear. Okay. Thank you.